Hey, thanks for inviting me to do this little intro. I'm really excited about the the Skyscraper event. So many great things to be talking about, especially with eVTOLs and urban air mobility, the advanced air mobility. There's so many things going on. I wanted to kind of focus in on those things that will be important to make this industry successful. And especially with what's going on with within the Latin America thing, especially with Philippe and Varen vehicles with their projects. So there's a lot of vehicles that are under development, many different configurations, and many of them have different missions in mind. But the basic details that they have that enable their configuration is electric drive, right? So now we can disconnect the power from the propulsion and come up with some crazy configurations and architectures that will make each mission unique and provide unique architectures. This market is such a convergence of so many different technologies, not just the vehicles, but the supply chain that's going to be required for these vehicles, the infrastructure that's going to be required, the electronics development, the power systems, the batteries, the power delivery. One of those major things that this project in particular is the air traffic management and weather predictions for micro scale aspects of weather prediction, and the real-time data that's being processed to make sure that operators and pilots have the information they need. The Vertical Flight Society has been involved with setting up and carrying forward the torch for eVTOL since 2014, when we first held our transformative vertical flight workshop, and it has just grown immensely since then. We just held our 7th one in January, and we had such a cross section of different parts of industry there, from the NASA and FAA folks to each of the OEMs, as well as many of the suppliers and infrastructure folks. The one that we held in January attracted over 500 people, and it was just amazing. And it's great to see that all these other things that are popping up around this industry, including this great program as well. And I'm really excited to see how this turns out. Philippe has done a fantastic job with organizing the think tanks leading up to this wonderful event. So I'm going to try to focus in on a couple of key aspects that we're working with the NASA folks under the Advanced Air Mobility National Campaign. One of the main ones is the supply chain challenges that we foresee being a problem, in addition to some of the infrastructure things. So as we get to a point where this becomes a really viable and energetic industry, we're gonna need to be building upwards of 10,000s of these vehicles per year. And quite honestly, the aerospace supply chain's not prepared for that. Neither is the infrastructure prepared for that. So we're gonna need everyone in the industry, and some industries that have never been interested in aerospace, to get involved with developing these vehicles. Groups that normally do things for commercial vehicles or military ground vehicles, things that are far outside the normal for aerospace. And these suppliers are going to have to be trained on what it means to be an aerospace supplier, and the kinds of processes and controls that'll need to be in place to ensure that they are providing quality product that's safe and usable in the industry. Among those will be electronics. As predicted, these vehicles will not only just require electronics for the propulsion controls, but the anticipation is that they will be autonomous vehicles at some point. Now, there's going to be different levels of autonomy that come into play over time, but having a high volume and reasonably cost supply chain for these types of electronics is going to be a key aspect. And electronics for aerospace is a unique animal in that the requirements for the design are so stringent to ensure that there's zero failures throughout its life cycle. And other parts of the supply chain, including, just the raw materials. Everyday devices use a lot of lithium and neodymium, but we're going to be using those in very large quantities, and we'll need to be looking at some additional raw materials that maybe aren't so commonly used, like samarium and cobalt. And oftentimes these come from places that we would perhaps call them as undesirable locations that don't meet quite the stringent environmental aspects that we'd like for them to meet to obtain those materials. So we're going to have to pay attention to those kinds of things as well as we develop this industry. And then ultimately, when we get to be fully electric, the power grid, even in the United States and other well-developed countries, won't really be there to support it if we don't take actions now to make sure that we have those things in place. So that's also going to require a lot of electronics and a lot of materials to ensure that that's in place. And then when you look at the infrastructure side, there's a lot of the materials and electronics needed for that don't exist today either. Speaking back on weather, just to provide the sensors in key locations that provide accurate and useful data will require a lot of different components to be provided to provide that information, as well as the air traffic management and understanding the communication protocols and making sure that they are completely safe from being intruded upon through cyber threats. And then, when we look at further into the infrastructure, we're going to probably be utilizing new materials that haven't been typically utilized for infrastructure and buildings. And we're going to need to look at different standards and processes to handle them and ensure that they are meeting the needs and being safe. With composite treatments for surfaces to ensure that they meet the minimum requirements. And really, they need to meet more than just the minimum requirements to support this industry, as the load factors and the utilization are expected to be very high. So you're going to see a lot of vehicles in and out of the same place. So understanding the wear characteristics of those surfaces and those buildings are going to be critical to ensure that there's no loss of utilization throughout the whole process of operations. Some of the other things is understanding the safety of these vehicles. We think we know pretty well the aspects of safety for aircraft and for helicopters, because typically helicopters come down vertically and they crash vertically. Airplanes, travel horizontally and typically crash horizontally. Not 100% of the time, but that's a good estimation. Whereas these vehicles will be doing both, so they need to be designed such that they are worthy of crash in either direction. And I don't think we, as an industry, understand what that means yet. And so I think we need to do a little bit of research there, as well as get some involvement from some of our esteemed research colleagues to look at these aspects and make sure that we do have standards and processes in place to ensure that these vehicles are safe. And that's important because if there's a perception that these vehicles are not safe, this industry will be forever grounded because of just from public perception. Other issues that we need to deal with include noise. We know what helicopters sound like. We know what airplanes sound like. These vehicles will not sound anything like those, and they will act and perform differently. And the public will have a different perception of these vehicles just based on the noise. So we need to understand and work to identify what the reaction of the public will be for the noise these vehicles will generate. The good news is that once they get off the ground and start forward flight, they're very quiet, basically silent. It's the takeoff and landing with the frequency of takeoffs and landings that will be important to understand what that looks like and sounds like. Further, we have potentially some really big workforce issues to deal with a lot of new rotorcraft programs underway, and and combined with the number of eVTOL aircraft projects that are underway, there's a huge demand for rotorcraft engineers of all shapes and sizes, from mechanical and electrical to aerodynamic. So we expect to see that there will be a shortage of these types of key and critical skills in ensuring that the future will be a safe and efficient one. And on top of that, mechanics and pilots. Mechanics, we don't really know what the mechanics will need to know what to do for these vehicles yet, since we don't have any in operation. But we expect that they will be different skills than what are needed for aircraft and helicopters today. And of course, pilots, we already had a bit of a shortage of pilots prior to the beginning of this year, but we're going to need, on the order of 30 to 50,000 pilots to start with, at least temporarily, until we get a process in place for automated flying. But what do we do after we get those 30,000 pilots? What happens to them then? So we have some other issues to deal with as well. But basically, what I want to summarize with is that this revolution, as we call it, the electric VTOL revolution, is on track to be underway in 2023. There's a thousand reasons why eVTOL won't work, but we have the intelligence and the knowledge to find the ones and go down the path that does work, and I'm confident that we will do that. eVTOL is the intersection, as I said earlier, of lots of different technologies and industries, from aerospace and automotive to electrical and electronics, advanced intelligence, and drones, and just new knowledge from all over that's consolidating into a single place that's going to make our world so much better. This is going to be a new industry, and it's going to take a lot of everyone's effort to ensure its success. It's not just a few people, it's not just a village, it's not just a factory, it's not just a state or a nation. It's going to take all of us. And we invite you from VFS and from Varen Vehicles to join us in leading these efforts and making sure that we have a successful and safe introduction to this industry. And so with that, I will turn it back over to Philippe, and I look forward to listening to the rest of the program.